Hi, thanks so much for coming. I'm Christopher Morse at Assembly OSM. Unfortunately, Adam Chernick was not able to come. I worked closely with Adam at SHoP Architects as well, so I'm going to do my best to cover his portion of the slides, but you'll just have to bear with me as I go through those. So I want to just start off just by introducing who we are, SHoP and Assembly, and what we do, because we are architects working on building buildings, and then we'll go to Thiasa to talk about the Sony RSD, SRD, and then, yeah. Okay, so if you don't know SHoP Architects, they're a firm based in New York City. These are some of the clients that SHoP has worked with. Primarily based in New York, most of the projects in New York, but they do have projects all over the world. Barclays Center, this is the Uber headquarters in this neck of the woods. Some embassy work, super tall towers in New York. The tower, currently finishing up the tallest skyscraper in Brooklyn, so that's very exciting. And you'll see a little bit about that. And you may have seen, if you were at the Unity talk yesterday morning, when they were talking about the digital twins, you may have seen a lot of SHoP videos from that. We work closely with Unity to augment our realities in architecture. So that's SHoP. Me, I'm at Assembly OSM. Assembly OSM is an offshoot from SHoP, so it started as a project in SHoP. We're now a separate company. We're focused on modular design for high-rise architecture and bringing architecture into manufacturing, or rather manufacturing into architecture. So here is just a quick video of what this is a prototype, physical prototype of what we're trying to do. What we're trying to achieve is building these modules in a factory with everything installed, all the plumbing, the wiring, the finishes, the kitchen, the stove, everything goes inside the factory. It then gets shipped onto site and stacked on site. So we're still very much in the prototyping phase, but this is our vision, and my job is to use XR technologies to help achieve that vision. Beautiful interiors. So this is the type of building that we'll be producing from those two prototypes that you saw. Those would be two parts of this one larger building.
All right, thanks, Chris. Hello, everybody. My name is Thiasa Yamamura. I'm head of business development for Sony Electronics, in charge of a new product called Spatial Reality Display. So before we talk about how it's being used on the architect space, let me introduce it to you. What is Sony's Spatial Reality Display? It's a new visual medium to see assets and create assets in 3D. It's a glasses-free 3D display that enables you to see assets in 3D without wearing any VR headsets or any special glasses. How it works is it's a 15.6 inches 3D display that works by connecting to a PC that it's running our SDK. It's connected via HDMI and USB-C because there is a built-in camera in the center of the display. So it uses basically 3 unique technologies from Sony. The first one is, as I mentioned, in the center of the display, there is this built-in camera that we have our high-speed vision sensor. And the other technology unique is the micro-optical lens that is seated on top of the LCD screen. And it processes the image in real time utilizing our real-time rendering algorithm. So those 3 unique features from Sony enables us to create this type of 3D, that very good 3D experience for our users. But let me explain in details how it works. So the high-speed vision sensor, when the person is in front of the display, as I mentioned, there is a built-in camera that tracks the position of the person in front of the display. And it divides the image between the right and left eyes. So each eye is receiving 2D image, and combined allow us to create this type of 3D experience. And then the micro-optical lens, it's a very thin lens that is seated on top of the LCD screen that also helps us to divide the images for each eyes, creating this type of stereoscopic image for the users. So it's a single person device that enables us to create this 3D experience. Here is a demo of how it works. So when a person is in front of the display, it detects the position of the face and the position of the eyes. And based on this information, it adapts the image for the user to see in different angles. So it really to create this experience as you were wearing a VR headset without having to wear one. So it enables you to see different angles and have a better understanding of the assets you are creating. So it's being used by different verticals. So it's being used by CG designers, architects, automotive designers, game developers, architects, product designers, on the virtual production, on volumetric capturing studios, on the medical field. Basically, anyone who are creating assets in 3D can utilize the SRD as a pre-visualization tool to better understand what they are creating. And specifically on the architect space, most of the time they are creating assets in 3D, and looking into a 2D screen, you're already like missing a lot of the details. In case of SHoP architects, they have been using the SRD as part of their designing tool, and as well as to show off the projects that they have to their clients, so they can have a better understanding of what they are designing. It's very easy to design the assets for the SRD. We do have a dedicated SDK that supports Unity or Unreal Engine. But basically, if you're already developing for VR headsets, it's going to be very familiar or easy to port your current assets. All right, so now Chris is going to talk about how he utilizes the SRD.
Yeah, thank you. So I just want to talk a little bit about how we're using XR, VR, immersive technologies within architecture space. I'll talk about my own work at Assembly, and then I'll also try to cover some of Adam's and his team's work at SHoP. Sorry. Getting ahead of myself. So the XR work at Assembly is we're developing custom things, but we're developing custom tools internally. So we're not developing software for others, we're developing it for ourselves. And similar to a physical prototype, a lot of what we develop are one-off tools to help us answer questions. And we think that augmented reality, virtual reality, immersive tools can be very, very powerful forms of communication, forms of learning, and ways to explore potential design solutions. So that's the kind of stuff that we're focused on, is how can we help ourselves understand our product, what kind of prototypes can we build to learn more about the physical things that we're trying to build. So in this case, on the left, we're looking at building a warehouse. We have to get this huge warehouse in order to build these modules. A lot of people on the team come from architecture. We're not used to manufacturing scales. We're not used to manufacturing sizes. So how can we use augmented reality as we're touring these potential warehouse sites to see a digital fit out, to see how much space we actually need. It's very eye-opening to walk in, go to the iPad and be like, oh wow, these things are huge. There's a lot of space that needs to go into these. Likewise on the right, doing digital assembly tests before we create the physical prototypes. It's a lot faster, a lot cheaper to create digital prototypes. Getting towards that idea of digital twin, I'm hesitant to use the term digital twin too concretely because it means so many things. But certainly that idea of using digital prototypes in order to learn, to facilitate. And one of the key things here is that it's not just augmented reality floating in space, it's augmented reality tied to a physical object. So we have the physical structure, we have that yellow steel, and we're overlaying things onto that. And that's very important for the sort of investigations that we're trying to do. Here on the left, you can see using the HoloLens, a prototype of, okay, let's see how we're going to lift this, how it's going to move over, how it's going to move in. On the right, how that piece actually moved in. A good anecdote here is as I was testing out the one on the left, we had an electrician working on the wiring, and he had never used the HoloLens before, and he just didn't know what it was, and he asked, like, oh, can I try that? He put it on, and immediately he watches the thing come in, and he's like, oh, that wire needs to go here because there's going to be blocks, so I need to change. And it was just an amazing use case of augmented reality for this type of problem where, with zero experience, it was immediately useful for him. So that was really exciting. Here again, sort of getting to that idea of the digital twin. So you saw the two mods that we were testing in the, two modules that we were testing in the factory. We're also building the digital versions of them, exploring ways to use that, whether that's augmented reality to visualize the internal structure behind it after we built it, or on an iPad. We're very interested in using the right tool for the job. So the work that we do, we want to be able to take all these very detailed 3D models and port them into whatever medium makes the most sense and filter the data for the use case. So some people need high resolution information of one part, other people need different pieces of information. So it's very important to tailor that 3D digital information to the use case, to the user who's using it for whatever problem they're trying to solve. In this particular case, we were testing out the vibrations. Like when you're doing a building, you want the building to be comfortable. As somebody's walking around, you don't want to feel those vibrations in other places. So we have some vibration structural experts, and they're using the HoloLens with the augmented reality structure overlay. And you can't see it here because I apologize for the video, but basically he's telling her where to go so that she's either standing on top of the structural part or not on top of the structural part, and so he's able to direct her using augmented reality to perform actual tests for comfort, for vibration. So again, this is something that was immediately useful. And we're finding that a lot, that we don't necessarily know. Sometimes we have a very specific idea, we're trying to solve this problem, and we produce a one-off thing to solve that problem. Other times, because that information is already there, other people just find immediate ways to solve it. Once again, visualizing in advance, we're not nearly at this stage yet, but we're trying to plan for when we do have the factory, when we are building out this thing, how much space do we need, what is the timing, what are the different processes. So visualizing this is very important for communication, and one of the things that's really important is being able to access that visualization, as I said, in different places, in different immersive contents. So what you just saw was on an iPad. This is that same visualization within a 360 projection space. And so the key features at Assembly when we're doing these XR tests, 3D information is what we live with. 3D information is almost always better than 2D if you can access it. Interactive is better than static. If somebody can react to, or if what they're looking at reacts to them, if they have control over it, if it's real time, it's a more immersive experience. They learn more from it. They communicate better. Connected is better than siloed. So going back to this one here, this is not a static animation. The data is coming from the manufacturing team that has their software to produce the timings. The design team has their software to produce the actual animations of the paths of where things go. So this is actually a very well connected, again, getting towards that idea of digital twin, but not there yet. And then, as I said, filtering that data. So we want to have that shared data and filter it to the users as they need it. And so we were lucky enough, so SHoP had a relationship with Sony, and SHoP was able to get their hands on the SRD. And I was lucky enough to have that connection with SHoP where they let us borrow it for a day, and immediately I was able to get that same visualization into the SRD. This video does not do it justice because you can't see the 3D, but it was just really, really amazing how quick and easy it was. I already had it in Unity. It took me 20 minutes to put in the SDK, hit build, and it worked in the SRD, and it was really, really exciting. So we're excited to play with this. We haven't, at Assembly anyway, haven't had a chance to use it a lot, but it falls in line with everything else that we're thinking. 3D is better than 2D, connected to data, ways to explore immersive displays, immersive information for the people who need it most. So we were very excited to have that opportunity. So I'm also going to run through some of the SHoP slides right now. And I did have a hand in some of this, but not all of it, so I'll do my best. I am not Adam Chernick. So there's a lot of similar, because Assembly came from SHoP, there's a lot of similar philosophy in terms of data, in terms of what we're doing with immersive technologies and why we're doing it. So I want to just get to some of the videos and show. So you've seen this one, augmented reality showing the buildings on site. This is really, really helpful for clients to view, or the public to understand what the impacts of these buildings are going to be in the future. On-site construction, so overlaying what is supposed to be there, what is going to be there, including drawings in with that. Very helpful for clash detection, for coordination. Importantly, connecting to data. It's not siloed. We want that information to be live. We want that information to be interactive. So that same augmented reality, look at the building going up, you can also see it just on your phone. And as the building is being produced, they're collecting data. They're signing off on, okay, this floor is done. From the app, you have access to that data as well if you're on the other side of the world. So it's sort of collected data filtered to the users that need it. Sensors, building environmental sensors and visualizing that. And a lot of this, again, is custom, it's bespoke, it's solving problems that we have, that we're trying to solve for ourselves rather than trying to sort of build a single solution for everything. And that allows us to be a little bit more flexible, a little more agile in terms of what we build and what we can do with it. Persistence is obviously important. So this is a test of creating, leaving notes, leaving comments, and integrating those notes, whether it's an AR or, again, in the same app, trying to connect that together so that you have all that information in one place. Immersive simulations. So we have this 360 immersive space. This is a really fun space. There are limitations to virtual reality where it's isolating. You're alone in virtual reality. There's limitations to augmented reality where other people can't see what you see in augmented reality. So this is a 360 room, a 360 projection space. It's not as immediately, you don't have that same presence as you do in VR, but you still have that immersive feel, but you can also be in that same room with people and talk about it together. So it's a more communal, but still immersive at some level. So we're really interested in, again, finding the right tool for the job and having that data be accessible in different tools and different platforms. In this case, they were looking at offices for a company where there were shuttles, there were bus shuttles coming in at periodic times, and they were worried that having all those people walk by all at the same time as that shuttle comes is going to be distracting. So we were able to go into the space, show several different design options for, well, we could put planters here, we could put this here, there are ways to mitigate that visual impact of people going through. And we were able to make a decision really quickly with the client that, yes, this works, yes, this is not obtrusive, this is what we want. Whereas without these immersive spaces, it would be much more difficult to make that decision as quickly. So as SHoP is building all of these, trying to move towards that connected suite of information, that connected suite of experiences. So the goal is that this data lives in a database somewhere, it lives agnostic to the end portal, and that end portal should be able to access it, whether that's an iPad, whether that's a VR headset, whether that's a 360 immersive space, whether that's a Sony SRD, the right tool for the right job, with the information filtered for the right question. I guess I'm going to skip through most of this. And yeah.
Yeah, so as part of the integration, SHoP architects, they developed the mobile app, and they wanted to find a way to integrate their application into the Sony's Spatial Reality Display. So whenever they show a project to their client, they can easily interact with the content from their cell phone. So they developed this where they can manipulate and rotate, interact with the content utilizing their SHoP Architects app, and then manipulate the project on the SRD and have this real-time visualization of the project they're showing to the client. And so they developed this tool for Sony's Spatial Reality Display, and this integration, this API will be also available for other companies in case they wanted to utilize for their own projects. So yes, that's it from our presentation. We have a demonstration of Sony's Spatial Reality Display on the booth number 927. So better than seeing on a 2D screen is to see it in person. So I encourage you guys to go take a look. All right? Thank you.
Thank you so much. Yeah, let's do a Q&A here.
Thank you.
Yeah, we'd love to answer any questions that anyone might have.
We have microphones on both sides of the aisle. We've got a question.
Yeah, hi, great presentation. I think I have a question for each of you. For the Sony SRD, it is a fantastic display. Curious where it is on your roadmap or whose responsibility it would be to move that closer to the authoring, whether it's a BIM tool or a modeling tool like Revit or SketchUp or something like that, being able to take advantage of the 3D display in the modeling environment, not just in a post-authoring visualization environment.
Yeah, so right now we are looking to different ways. I'm happy to discuss whether, if it's part of our pipeline.
I'll also just jump on that and mention that there's lots of efforts at different places, whether it's NVIDIA Omniverse, Unity Reflect, for getting that live data from a design environment to a different screen or different immersive space. And so I can definitely see a future where, yeah, you're still in Rhino, you're still in Revit on a regular screen, and you have your SRD right next to you, and it's being piped to it via some other server, some other service, and so you can sort of have both together. That also seems very, very doable.
Yeah, right now we only have the SDK for Unity or Unreal, but we are looking to provide different formats, compatibility.
Sure. And then a question for Christopher. It looked like you had occlusion culling in some of your video up on the shop floor, and I'm curious how you pulled that off with a HoloLens.
Black material. Yeah, in order to do that, I have the structural frame. I have that model as well, digitally. It's not world detection. It's a digital model of that I slap a black material on, and voila, occlusion culling.
Makes sense. All right, thanks.
Question on this side.
Hi.
Hey guys, really great presentation. We work in the architectural space for AR and done some fabulous things. So we work with a lot of architecture firms, but what's interesting about emerging technologies is that there's this it's hard for them to adopt. And so what was the inspiration from SHoP that got you guys to say, we're gonna take these risks, we're gonna take these chances, especially one thing you said about AR, letting the clients see it. You will not believe how hard this is to get people to take such a risk. But of course, when the client sees it, they're like, holy shit, that's my building, oh my God. And you let them run around and they're going wild. So for you, what is it that's special about SHoP that makes you guys say, we're gonna take these risks on emerging technologies and try brand new things?
I mean, that's exactly what makes SHoP special, is the willingness to do that. I mean, that's part of SHoP's DNA, is understanding or believing in the potential of emerging technologies. And I'm talking about XR because that's what I do, but it's not obviously restricted to just that. There's a lot of things going on at SHoP. And from the very beginning, the partners have been interested in taking technology and architecture and bringing them together. And I think it's also really important that, when you look at the SHoP buildings, they're beautiful buildings, and they're not necessarily, you can't tell necessarily that what technology was used to make them. So there's use of technology in pursuit of how do we make it faster, how do we make it cheaper, how do we make it better, but there's still that aspect of design in it. And that's just always been there from the beginning. I can also say that it's easy when you have the computational skills already in the office, when you have the visualization skills already in the office, you really only need, and because we're not developing software for a wide scale, we're developing bespoke one-off solutions because each building is different, it's actually not as hard of a lift to find a person or two people who can handle Unreal or Unity and build that out. But it comes from the top. It really does come from the partners being willing. They love putting on the headsets. They love seeing this stuff, and it really has to come from there.
That's right.
We're actually out of time here, and we have one more question over here, so let's just make it super quick. Thank you.
Okay, so just quickly, looking at it from a marketing and sales perspective, architects often view this as an expense, augmented reality. But architects charge for models, for physical models, they charge for physical mock-ups, they charge for renderings. Do you see this as a revenue opportunity for architects?
That's a really good question. Yes and no. I think there's opportunities for that. We have done that. We have produced, in the same way that SHoP will produce renders for a fee, we have produced VR walkthroughs for a fee. We have done that. But I think the importance is beyond that. I think it comes from, and it's hard to put a number on it, but when the example is with the 360 space, we had the client in there, and we were able to make a decision so much faster. And that speed of decision, or you get a better outcome. And there's no easy way to put a number on, once you spent time in VR and you've looked at the scale and you've thought about the materials and the solution that comes out is better. But how do you quantify that? We don't.
Right.
We don't need to. We understand that it's better. So both, I guess.
We think of those as well-informed, sticky decisions. The decisions that are made in our AR are well-informed.
Mm-hmm.
So that's what you do.
Thank you. I'll be outside if anyone else wants to ask questions. Feel free to come up and say hi.
Thank you
All
so
right,
much.
thank you.
Yeah.